So in this way, each element's cofactors we have to find out. Now this is A2 negative value because minus 1 is for 2 plus 1. 2 plus 1. Number of row and number of column. This indication is here. The numbers are added up here. Minus 1 is power 2 plus 1 into determinant value. Okay, this is minus 1. Minus 1 is lying in the second row. This row is left over and this column. It is 2, 0, 5, 6. 2, 0 and 5, 6. Because this minus 1 lying in second row got left over, removed, and this is removed, not considered, and this column is also not considered because minus 1 lying here. Minus 1, we have to not multiply with minus. These numerical values are not multiplied to the determinant value in this case of cofactors. But when we determine the value of any determinant, then we multiply by that value. That is the difference I'll talk about in case of determinant value. When we determine the value, or in case of determinant, we will talk about how to find the value of determinant of any matrix given. That determinant we will talk about in case of determinants, but still we have to find out a determinant value like this. 6 into 12. This is minus sign here, minus 1. Okay, because minus 1 is for 3 is negative value. Into other bracket 6 to the 12 minus 0. 5 into 0 is 0. It is 12 minus 12 here. It is minus 12. Because minus 1 into 12 is minus 12. So this is minus 12 value. Okay, now let's talk about A2. So alternate negative positive, it is coming on. Next will be positive value. A21 is negative, this is positive, this is negative, this is positive, this is negative, this is positive. In this way, alternate, because these numerical values, these star values, these subscript values are showing that negative positive. How to add them? 2 plus 3, 5. 5 is odd number, so negative sign it will be minus 1 is 4, 5 is negative. 2 plus 2 positive, 1 plus 3 negative, 1 plus 3 4, 4 positive value it will give us. Well, minus 1 is 4, 4 is positive. Okay, so now A22 we have to calculate. A22 is minus 1 is 4, 2 plus 2 positive. This is not considered because just we imagine that 2 plus 2 is 4, so it is even, or we take alternate negative positive. Okay, in that way also we can consider. We have to just find out determinant value. A22 is 3. Now 3 is lying in the second row and second column. It is 1, 0 and minus 2 and 6. Okay, this is 1, 0 and minus 2 and 6 for this column, and this row left, second row and second column is left over, is removed, and 1, 0 and minus 2 and 6 is left over. Multiplying them, it is even number. This power is even, it is positive value, plus sign in bracket. 6 1 is 6 minus 0 because minus 1 plus 0 minus 2 into 0 is 0. It is 6 1. It is plus 6 value. A22 is calculated. Now let me take other values also. Calculate the other values. A23. Now A23 is negative value. Because it is 2 plus 3 negative, it is minus 1 is 4, 5 into determinant value. This is of 4. A23 is 4. This row and this column is left over. This is 1, 2 and minus 2 and 5. 1, 2 and minus 2 and 5. Because we have to leave this row and this column. 1, 2 and minus 2 and 5 is left over. It will be negative sign. Minus 1 is for 5 is negative. 5 1 is 5. Now minus 1 is plus because minus sign is here. Minus 2 is 4. Minus 4 into minus sign is plus 4. It is minus 9. But 5 plus 4 is 9. But negative sign is minus 9 here. Okay, now the remaining 3 numbers values. And the other values let me just find out. A31, last row. The value lying in the last row. A31 is a positive value because 3 plus 1 4, minus 1 is 4 4. Determinant value of this row and this column, first column and third row left over, it is 2 0, which is 3 4. Okay, it is 4 to the 8, it is positive value because non-funny for 4 is positive, it is plus sign in within bracket. 4 to the 8 minus 0 because 3 into 0 0. It is 8 only positive value. It is 8 only. Alright, next A32. It is A32. Negative value because non-found is for 5, 3 plus 2 5. Okay, and into written value of 5. Now this value A32 is 5 here. So what is this row, this column, sorry, and this row left over? It is 1 0 and minus 1 and 4. Minus 1 and 4, 1 and 0. This column and this row is left over. Now value, removed. So those values are, those rows and columns are removed, and whatever value left over, the remaining in the our left over rows and columns, that value is written down here. This is 4 into 1. It is negative because minus 1 is for 5 is negative sign. 4 into 1 is 4 minus 0. Or it is minus plus here, plus 0, but it is minus 4. It is A32. Now last value. So the last value is A33. A33 value, the cofactors value A33. The minus 1 power is 3 plus 3, 6. Okay, these values I plus j is added up. Minus 1 is 4 power. Now it is positive, even power, so it is positive. Minus 1 is power, even number is positive. Okay, so this column and this row left over, so this is 1 2 and minus 1 3. 1 2 and minus 1 and 3, but this row and this column left is removed, or they are removed, and after that whatever left over, that is taken here. 3 into, this is positive value because minus 1 is for 6 plus even the 3 plus minus 1 into 2 is minus 2, but minus plus here. But in between we put the minus sign, but this negative sign comes here. Minus 1 and 2 is minus 2. It is plus 2 now. It is 5. It is 5 here. Finally, the matrix of cofactors is obtained. These values are here. Let me put them. This is equal to A11 is minus 2, then minus 2 here, then A13 is 1, then A21 is minus 12, okay, then 6, then minus 9, A23, and A31 is 8, this is minus 4, and this is 5 here. This is matrix of cofactors. Now we transpose it. Sometimes what problem occurs, that the students find out the matrix of cofactors, but after that they do not transpose that, and they leave that this is a cofactors matrix. So that answer is wrong. But still, adjoint of a matrix is not calculated. Is still unfinished task. We have to complete this task. What completion? We have to transpose this. Transpose of the matrix of cofactors is the adjoint of the matrix. Therefore, adjoint of adjoint A matrix will be, this row will become column. This is minus 2, and 1. Second row will become this second column, minus 12, 6 and minus 9. Then it is 8, minus 4, and this is 5 here. This is the final value. Adjoint of a matrix is a systematic process, but we have to just calculate that. Okay, otherwise sometimes the students leave only up to this cofactors. They do a lot of labor in case of finding out cofactors matrix, but after that they just forget that they do not transpose it, and then they say that this is adjoint of matrix. My answer is is not, this is half calculated, so we put them half marks, or sometimes because the answer is wrong, but we do not put 0 because marks are not 0 because they are finished, they have done something, they have delivered a lot. So we give them half marks, not complete marks or full marks. Full marks are offered only when the complete task is done, because mathematics is exact science. We have to find out the exact answer. Answer is exact. One answer is there. No two answers are there in case of mathematics. So this is now complete. Adjoint of A is transpose of the matrix of cofactors. Transpose of the matrix of cofactors is known as adjoint of the matrix. Now this is the final answer. Still, this is not the answer. This is the answer. This is the final answer. Question number 4. Here we have calculated adjoint of the given matrix. Adjoint of the given matrix is, find the adjoint of A. A is given here. This is the adjoint of the matrix A. Question number 4 is completed. Now we have to find out, we have to prove one property of adjoint of matrices. Now adjoint of the matrix, this is square matrix mostly. Adjoint of the matrix is calculated only of the square matrices. Square matrix it must be. Only then we find out adjoint of the matrix. Inverse of the matrix is also calculated of a square matrix. Similarly, adjoint of the matrix is calculated of a square matrix. So it must be a square matrix only, not any matrix, not a rectangle matrix. A square matrix is only calculated. Now verify the term A is equal to A into adjoint of A is equal to adjoint of A into A. Okay, but I just remove that value. Okay, if I just multiply that value, I just calculated adjoint of that matrix. Okay, if I just multiply that value to A into adjoint of A is equal to adjoint of A into A equal to determinant value of A into I. This we have to calculate. Now I'll take our square matrix only, so it can be done easily. Okay, so that let me take not of order 3 but of order 2. A square matrix of order 2 are okay. Question number 5 here we have to verify here, or to verify, not find, to verify theorem, verify the theorem. But the theorem here, A into adjoint of A is equal to adjoint of A into A is equal to determinant of A into I. Determinant of A will calculate. How to find out determinant of A? Okay, that we will calculate. But before that, okay, so we have to just calculate the determinant of A here. Alright, so determinant of A, let me take one matrix here, then matrix of cofactors we will calculate. So let me take, just to solve it, or it is proof here, verification or solution. Let me take, it is a solution here. Solution, let A is a matrix, a square matrix. Let me take this 2, 3, 1, 4. No problem. This is the matrix. Let A is equal to this, a matrix. A matrix is a matrix of order 2, a square matrix. This is a square matrix. We have taken a square matrix of order. Oh, this is 2 by 2 order. This is order. So a square matrix we have taken. Now let me take adjoint of A. We have to first calculate the determinant of A. Determinant of A, if I calculate, determinant of A is represented like this and multiply them, the value will be, this is 2, 3 and 1, 4, that means 4 to the 8 minus 3 1 to the 3, that means 5. So determinant value is 5 only. And identity matrix is, what is the identity matrix here? I is the square matrix here. This is I to here, because I have taken I to here. Sorry, Because in this case this is square matrix, so I2 will be identity. So this is identity matrix or unit matrix. This is 1 0 0 1. 5 into this is 5 0 and 0 5. This is the value determinant A into I. Okay, this is your right hand side finally. This we have taken. So we have to prove that this adjoint of A into A or A into adjoint of A into adjoint of A, they are also coming out the same values. Let me write it here. So we have just calculated that determinant value is 5. Okay, 4 to the 8 minus 3, and I we know this is okay. I determinant value A. Now let me find adjoint of A. What is adjoint of A? Adjoint of A. Now adjoint of A we have to calculate. It will be transpose of the matrix A11, A12. We just write this so that the systematic name A11, A12. In this case, it is A21, it is A22. Only 4 elements are there. This is square matrix and transpose of this. This we have to calculate. So it will be, let me find out here. This is A12, sorry, A1 and A12. Finally, we have to calculate, and this is A21 and A2. This we have to calculate determinant. Sorry, this adjoint of A. Adjoint of A, for that A11 we have to calculate. What is A11? Let me just find out from here. A11, in this case, only 4 is there. It is positive value. The minus 1 is for 4 cofactors. A11 is cofactors here. A11, A12, they are the cofactors here. Cofactors when only square matrix is given, this row and this column left over. So what is 4 left? Only 4 is the value. This is positive. So this is 1 plus 1, 2. So this is 4 only. Positive value 4. A11 is 4. Here it is 4 here. Let me just write here. It is 4. Adjoint of A. Okay. Then this is A11. We have calculated. What is A12? A12 means this adjoint 3. Adjoint of, sorry, cofactor of 3. Cofactor of 3 is 1 only because this row and this column is left, so 1 is left. But it will be negative because A1, 1, 3 means minus 1 is 3 into this 1. So this is minus 1. This is minus 1 here. Get this calculated, transposing this whole value is this. The final answer adjoint of A. Okay, so this A12 we have calculated. Let me take A21. A21. A21 is a cofactor of 1 is 3 here, but it is A21 odd number. Okay, so A21 is minus 1 is power 3 plus 1 3 negative value, and it will be of 1, so it is 3 only into 3. It is minus 3 here. So negative value A21. Okay, and this is negative, so this is minus 3 here. It is minus 3. A21. I'm sorry. Here we have to write A21 is this. What I'm writing A21. I've written down. I'm sorry. I'm just first calculating this. So A21 is minus 3. It is minus 1 here. A12 is here. It is minus 3 here. A22 and A11 they are not. They have remained the same. Only A12 and A21 they have interchanged here. There is a difference only. Minus 3 the value of A21. Minus 3. A21 is coming here after transposing. Okay, then A22. What is A22 value? Let me find out A22. A22 is positive value because 2 plus 2 positive 4 value. And A22 means this value. So cofactor of 4 is 2 only because this column and this row left over 2 is they are removed, so 2 is only left over, so 2 into plus 1, that means positive 2 plus 2. After transposing, we have just put these values here. After transposing, this is output. This is adjoint of the A matrix. Okay, now let us prove the adjoint we have calculated. So this is the adjoint of A. Adjoint A is this 4 minus 3 minus 1 and 2. Now let us prove the theorem. Now what are the other values? Okay, so other values are, okay, we have to multiply this with A, because A into adjoint of A. Now left hand side, A into adjoint of A into adjoint of A equal to A is this value 2, 3, 1, 4, and this is 4 minus 3, this is minus 1 and 2. Multiplying them. Okay, it will give us this first row, first column, then second column. 2 into 4 is 8, 3 into this minus 1 is minus 3, 3 into minus 1 is minus 3 here. Okay, then first row, second column, 2 into minus 3 is minus 6, 3 into 2 is plus 6, it is 0 here. Okay, no problem. Then second row, first column, 1 into 4 is 4, 4 into minus 1 is minus 4, 0. Okay, then second row and second column here, 1 into minus 3 is minus 3, 4 into 2 is 6 here, sorry, 4 into 2 is 8 plus 8. Alright, so 1 into 3 minus 3 minus 3 this minus 3, 4 into 2 is 8. So what is the final result? 8 minus 3 is 5, minus 6 plus 6 is 0. Alright, this is 4 minus 4 0, minus 3 plus 8 is 5, positive. Same value is obtained. It is 5 if I take common. It is 5 into 1 0 0 1. So which is determinant value A into I. Same value is obtained. Okay, this is in case A into adjoint of A. If I find adjoint of A into A, we have to check that also. Only in that situation, we have to just write first adjoint of A, this value, just interchanging them. We have to interchange them. So first write adjoint of A, because second part is this adjoint of A. This is 4 minus 3 minus 1 and 2. Then A is 2 3 1 4. Let me just calculate this. Now first row, first column multiply, then first row, second column multiply, and then second row, first column, second column. Let me take 4 into 2 is 8, minus 3 into 1 is minus 3, alright, and 4 into 3 is 12, minus 3 into 4 is minus 12, alright. Okay, this is corresponding multiplication. 4 into 3 minus 3 into 4, 12. This is 12 minus 12. Then minus 1, second row, first column, minus 1 into 2 is minus 2. 2 into 1 is plus 2. Then minus 1 into 3 is minus 3. 2 into 4 is plus 8. Minus 1 into 3, minus 3, and 2 into 4 is plus 8. Same value is obtained here. This is 5. 12 minus 12, 0. Minus 2 plus 2, 0. Minus 3 plus 8 is 5. Alright. So 5 if I take common, then it is 1 0 0 1. This is also determinant value A into I. Okay, so hence it is proved. This theorem is verified. This is regarding adjoint of matrix. Adjoint of A, adjoint of a matrix given. This theorem is proved. Hence, this is equal to adjoint of A into A, or A into adjoint of A is equal to determinant value A into I. This we have proved here by taking this illustration. Okay, this is question number 5. Now let me talk about question number 6. What is question number 6 say? Let me check it. question number 6 here. What is question number 6? Let me check it. Now question number 6. Now it says compute the adjoint of A given by the matrix A equal to this, and verify adjoint of A equal to this. Okay, here we have to compute 6th question. Compute the adjoint of A given by A is equal to, this is adjoint of A. We have to find out of this determinant what is A here. This is 1, 4, 5. This is 3, 2, 6, 0, 1, 0. This determinant is given to us, sorry, this matrix is given to us, and we have to find out. Compute the adjoint of a given matrix A is this, of this matrix A, and verify the adjoint. The same term we have to, and verify. And to verify the theorem, the same theorem we have to verify here. Okay, this are to just solve that adjoint of A, that means A into adjoint of A equal to adjoint of A into A equal to determinant value A into I. This we have to prove here. Again, let me take A here. So the adjoint of A matrix is adjoint A solution we are finding out. Adjoint A is determinant of cofactors matrix A11, A12. Here it is 3 by 3 order. A13, A21, A22. It is A22, A23, A31, A32, A33. Okay, and transpose of this. It will give us, we have to calculate each element of this matrix of cofactors. This is matrix of cofactors, and transpose will give us A11. This is, first let me write this A12, A13, A21. This second row becomes second column, A21, and this is A22, A23, and this is A31, A32, and this is A33. Okay, so this is, we have to find, this is after transposing. This is adjoint. Now we have to calculate this each and every point of this. This I'll take after 5 minutes. Okay, see you then in the after 5 minutes.